Introduction to Combinations. Welcome to the lecture on combinations. We're going to explore the concept of combinations, which is a selection of items from a larger set where the order does not matter. So unlike permutations, combinations focus on selecting items without regard to their sequence. This is important in many fields, including mathematics, statistics, and probability. Why study combinations? Why is it important to study combinations? So combinations are essentially in solving problems related to selecting groups or subset of items. So for example, in a lottery, we need to calculate the probability of selecting a winning set of numbers. In team selection, we often need to choose team members from a larger group. Combinations are also used in combinatorial chemistry to select uh, chemical compounds for experiments and so on. Basic definitions. So if we start with some basic definitions, a combination is a selection of items from a larger set where the order does not matter. So the binomial coefficient, often referred to as n choose r, represents the number of ways to choose r items from n items without regard to the order. So the formula for calculating combination is n factorial divided by r factorial times n minus r factorial. Basic combination example. So let's look at our first example. Calculating the combinations of 3 items taken 2 at a time. You can use the formula to calculate. So n factorial divided by r factorial times n minus r factorial. Using this formula, you will set n to 3 and r to 2. So plugging in these values, you get 3 factorial divided by 2 factorial times 3 minus 2 factorial, which comes out to be 3. Therefore, there are 3 combinations: 1, 2, 1, 3, 2, 3. If you were to use Python to calculate this, you would first import the math module and you specify value of n and r. And math module has a function name called com, which calculates combination, and you pass n and r to calculate combination. Example 2, combinations with larger sets. So if we consider a larger set, we want to calculate the combinations of 5 items taken 3 at a time. Again, you can use this formula and you can set n to 5 and r to 3. By plugging in these values, you get 5 factorial divided by 3 factorial times 5 minus 3 factorial, which comes out to be 10. So there are 10 combinations, which includes sets like 1 to 3, 1 to 4, 1 to 5, and so on. Applications of combinations. So combinations have many practical applications. In lotteries, we can use combinations to calculate the probability of winning by selecting a set of numbers. In team selection, we determine the number of ways to choose team members from a larger group. In combinatorial chemistry, combinations help us select chemical compounds for experiment. And here is an example of choosing team members. You can use iter tools and define a list of team members, and you can call iter tools combinations and specify the second parameter to be 3 because we're choosing 3 from 5 members, and this returns iterators, so we will convert this into list. Combinations in probability. So combinations are also important in probability. They help us determine the probability of selecting a specific subset of items from a larger set. So for example, in a card game, we might want to know the probability of drawing a specific hand. So by calculating the combination of possible hands, we can find this probability. This is important for making informed decisions based on the likelihood of different outcomes. So if we look at this code, we first import the math modules and define total numbers and chosen numbers, and we can call combination function from math module and provide total numbers and chosen numbers to get total combinations. Exercise 1. So let's take a look at more examples. So here is the problem. How many ways can you choose 4 items from a set of 10? You can use the formula n factorial divided by r factorial times n minus r factorial to calculate the number of combinations. If you use Python, we have this combination function from math module. So we can just call this with n respective n and r value. Now exercise 2. How many ways can you select 2 books from a shelf of 7 books? We know that this is a combination problem because the order of selecting the book does not matter. So we can use the combination formula. If you're using Python, you can use comp function from math module to calculate this. Moving on to exercise 3. A committee of 3 members is to be formed from a group of 8 people. How many different committees can be formed? We know that the order of selecting a committee member is not important, so this is a combination problem. So you can use the combination formula to calculate the number of possible committees. If you use Python, you import the math module and call comp function to calculate the number of combinations. Conclusion, combinations are selections of items where the order does not matter. You can use binomial coefficients to calculate combinations, and the formula is n factorial divided by r factorial times n minus r factorial. Understanding combinations is important for solving various mathematical problems and real-world applications. Thank you everyone for listening.